We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
I'm Jon.
And I'm Keith.
And I'm Jon.
And this is Flumadiddle, your somewhat reliable source of information for most things, Keith.
Most things, Jon.
Most things, including but not limited to events of major historical importance, such as
sending guys back to the moon and the first lady back to the moon for the first time. And so very important stuff we're working on. And we have Dr. Jon Blevins with us here today.
Yeah, he's the chief engineer for the SLS program. And Jon, we're going to go off script. We're just going to throw a curveball right off the bat here. We're going totally off script. First question, speaking of things of major historical importance, you've been in Huntsville for a while. So we like to have the local take on where the best barbecue, pizza, and breakfast is. Do you have any favorite restaurants you can share with the folks if we come to Huntsville?
Yeah, I sure do. Barbecue, there's a lot of secrets and I've got to be careful there because I might be, limited when I go out. If somebody hears that I favor Moe's over Gibson's or something like that.
Yeah.
But in this group, I'll go ahead and tell you Moe's is my favorite.
Okay.
The one downtown. So that's where I go for the barbecue. Hey, for pizza, I get it in a box. Don't you guys get your pizza in a Sam's? That's a great place to get pizza. So, and then engineers are always about efficiency. And so I would have to throw out a shout out to either Chili's or Jason's Deli. Those are, I know they're just places that are normal, but Little Rosie's is a Huntsville gem. So get your Mexican food at Little Rosie's. So.
Yeah, I think Keith's been there before.
I have a few times. It's very good.
Excellent. Well, thank you so much. Keith, why don't you take over for just a minute?
All right. Well, Jon, if you don't mind, let's just start with this. Just tell us a little bit about yourself and the SLS and what that is and your role with the program.
Yeah. Okay. So I'll just start out with a little bit of background. A lot of your viewers may not know how you get to a spot like chief engineer for a rocket that's going to the moon or something. And so I grew up as a preacher's kid in Tennessee and different places in Tennessee. And when I got to be about 18, I wanted to go to the Air Force Academy, and they had bad news for me. They told me that unless I had 20/20 vision and everything, I couldn't go. And I had like 20/25 when I got tested for the Air Force Academy. And so I ended up going to Tennessee Tech, and I had a great time. That was God's way of directing me to a good place. And so Tennessee Tech was a great opportunity for me. I enjoyed being there. After that, I went and designed cars for a few years. And my wife was doing something. We lived in Ohio at that time. And ultimately, we had the opportunity to come down to Huntsville, Alabama, and I went to graduate school for 5.5 years at the University of Alabama in Huntsville as a full-time student. As you know, there's a lot of people in town here in Huntsville that go to UAH and get grad degrees, but I was one of those full-time students and studied a lot about aerodynamics and fluid mechanics and thermodynamics. Still not really a huge NASA person. I'd grown up, I can still remember people walking on the moon. I'm in my mid-50s.
Okay.
And so I can remember that. And of course, I loved the space shuttle and I wanted to go to the Air Force Academy, but when they told me I couldn't fly for them, that kind of turned me off. And so that rekindled a little bit during grad school, but I went to work for a private company for a while, and I picked up flying as a hobby. So I do a lot of flying and enjoy that. And ultimately, one of my grad school friends called me one day back in the 90s and said, hey, NASA's hiring again. Would you be interested in coming down here? And so I did. And I've had several jobs at NASA during the decades I've been there. And it's been good. And ultimately, we work at the pleasure of the administrations and Congress. And when they started this program to return to the moon, it came on the heels of a program I was very involved in, the Constellation program, the Ares rocket. And I'd worked a lot of aerodynamics and things in that rocket. And I guess I'd known a few people. And so they invited me to have a larger role in this rocket. And so I led aerodynamics. And then subsequently, they asked me to come and be the chief engineer. And so I've had a great time being the chief engineer. We've got a lot of other chief engineers for the individual elements. I get to be the program chief engineer. So I work with all of those guys, the boosters and the stage, core stage, and all of our payloads. And I'll have chief engineers I assign to those tasks. But so that's a little bit about me and how I got to be chief engineer. The Space Launch System is really the backbone of the Artemis missions, the Artemis program. that you talked about. It's the one vehicle that's set up to carry humans back to deep space. So there's a lot of other programs out there, and you see some of them. For instance, we've taken low Earth orbit and we've given that domain, if you will, to our commercial crew partners. Now that's still a NASA program. NASA still funds that. That's still your tax dollars, but it's a program where we take a different tact at how we buy that rocket. And of course, we work with commercial companies, right? Like Boeing's building the core stage, Northrop Grumman's building the rocket. So some of the same people that are doing different programs are involved in all of these. But so commercial crew, they do the low Earth orbit, so they go 250 miles away to go to the space station. Our goal is to go to the moon, which is 250,000 miles away, or go to Mars, which can vary. It can be up to 250 million miles away, but it can also be 62 million miles away. And so those are some of the things SLS is set to do. Now there's other rockets that'll be in that Artemis program, but SLS is the one that carries the humans in that program, and it's capable of the largest payload since we had the Saturn V, since the Apollo missions. And so that's a little bit of SLS, but I'd love to answer all your questions on SLS.
Right.
Yeah, well, I mean, it sounds to me like you're a part of something that's historical in nature. I mean, you literally could be writing history. What does it feel like to be a part of something like that?
Well, I've always thought that people in the middle of those big things, whether that's a D-Day or something like the Apollo missions, they're really getting their job done daily. And it's a reflection that we have that we're part of something bigger as history. I will say, though, that we do recognize how monumental it is. And when you're in the middle of something like that, whether it is like a D-Day invasion or some other big thing, I think you can look around. And what you can see is that you could not do this alone. And that the product of all these people's labor, the net sum result, is greater than just the individual additions that we could do, right? That product of having just some of the smartest people I've ever worked with solve problems around you and is just great. So I don't know that we think of it as history, just like those that have done other things as much, but we do recognize the importance for our country and for the world to try to succeed at these missions.
Awesome. Dr. Blevins, from what I read, the plan is, if I understand correctly, that LSS or SLS, it'll continue on beyond the Artemis mission, possibly Mars, whatever. But right now, what's on the horizon, or what's right here in front of us, is the Artemis mission. And from what I've read, are we still hoping that Artemis 1 will take place by the end of the year? And explain to the folks a little bit more what the Artemis mission is and what we're hoping to accomplish with that.
Yeah, that's a great question, John. So we do hope to fly that mission by the end of the year. And the reason I say we hope to is because we have things that we're going to achieve between now and the time we fly that mission. And those things are very important for us as an agency so that we can be safe for the next mission. Artemis 1 is a test flight that nobody's on. And so we're putting this hardware together right now. In fact, I just got out of a meeting where we're talking about our test that's going on next week at the Stennis Space Center, which is testing out our systems. It's a test we're only doing on the Artemis 1. And there's many tests that we'll only do on the Artemis 1 hardware. Like when we put it together down at Kennedy Space Center, we're going to shake that rocket. So we'll have this rocket together in a few months. And so if we wanted to fly it this year, like if somebody said, you got to fly it this year no matter what, well, that's not the challenge. The challenge is, can I learn enough information out of this integrated rocket so that when I put my friends, the astronauts, when we put them on the next flight and we send them 250,000 miles away, will we have confidence that all the systems will work? So if you want to know what the delay is, if you will, or why I say I hope we do it this year, it's because we're doing some testing. And whenever you do testing, you're answering questions you don't know the answer to.
Right.
I mean, that's kind of if we knew the answer, we wouldn't be testing. And so some of these things that we're doing, we want to understand them. And so we may go one step and we'll test the vehicle and we'll say, I don't understand, or I don't like the way that responded. The compliance in a joint, for instance, or the response when we shake it as an integrated vehicle. And we may say, is our finite element model good enough to match that response that we saw in real life? Because we believe what we saw in real life. And so we will tweak those things. And we want to be good enough that when we fly this first time, that we will have every confidence to put human lives on there, to go to the moon and around it, very similar to an Apollo 8 mission for the second flight. So yes, we do plan to fly it this year. I think that schedule is very achievable, but what we're going to do is do it right.
Absolutely. Well, let me ask you this. We've been to the moon before. I think some people maybe think, hey, we'll just dust off all that old Saturn V stuff. We'll kind of chunk everything together. And hey, that should be really easy. Take us a couple of weeks to get that done, right? So from what I understand, the engines, is it RS-25? Is that what the engines designate?
Yes.
Those have flown before on the space shuttle. So there is some reuse of old stuff, but a lot of this technology is new. You can't just pick up, I think I listened to your Science Friday stuff from a couple years ago. You can't just pick up some plans from Saturn and just slap this thing back together. So how from that perspective, how's this coming together with new technology and such?
Oh, it really is coming together pretty well. You hit on kind of the newest, biggest part is this core stage that has the engines on them. And those engines, the first 16 that we fly are heritage engines from the space shuttle. So they've all got some flight history to them, which is kind of neat. We recovered everything during shuttle. On this rocket, we don't plan to have that flight rate to justify all that recovery. Right. And so it'd be cheaper to, and also a better concept of operations to let it all go. That way you can, kind of not worry about return to landing site or the sea state if you're going to drop boosters in the ocean, things like that. So you optimize your launch availability if you throw things away as you go in this world, just like the Apollo guys did.
Right.
They threw it all away, right? And they're not dumb. So I feel pretty good company when I say it's the best choice for this particular architecture. But the core stage has a lot of different things in it. One of the things about new technology that you mentioned, John, there is I don't think people understand how we're using it very well. We're making a rocket that's both more reliable and yet cheaper than what they made during the Apollo times. So even some of the people that would be maybe negative about a big rocket, and there will always be people negative about a government program. It's kind of something that happens. And there was during the Apollo time, if you go back and look at that. And so some of the people that are negative have looked at our rocket and they still say, oh, well, at least you're a lot cheaper than the Apollo was. Well, that's an outcome of that technology you're talking about. So we're using technology really to minimize the workforce, to minimize the costs, and to improve the safety. So that's a lot of the things that we're doing. Automation, for instance, automatic processes. Some of what we use is in terms of our gyros and things like that. So a lot of the advanced technology, if you want to refer to it that way, and it is, would be in our core stage because it's kind of the newest part. The boosters aren't the same as the old boosters,
right? But
they're similar. When you look at them, you'll say, oh, that's the same. They're not the same, but they're close. Right. The core stage is, big panels of steel rolled into the factory, and the core stage goes out of the factory, and a bunch of stuff goes in, wiring and, right. Instruments and all that stuff. Hey, my computer almost timed out on me there for a second.
Okay. Hey, we still got you. We didn't lose you. Keith?
So, you mentioned that one of the things that does delay is that you want to make sure it's safe and everything. I know that COVID's probably set back everybody in the world, but has there been any other major setbacks, any things that you've had to persevere through?
Well, first, let me say that COVID is a challenge for everybody, and there's probably some people out there that may watch this YouTube or podcast, and they've struggled with it. So first, just recognizing the state of the world, it's been a challenge for everybody. In fact, we've got a guy right now that's crucial to our team that's in the intensive care, and he's been there for 6 weeks on a respirator. So I want everybody to take care of themselves out there. We've been working at home. This is one of my 3 or 4 locations in my house that I tend to work in. I put the dogs in the basement so they won't interrupt us. But what I've been amazed at, well, if yours hears mine, then we might have a problem.
Exactly.
One of the things I've been amazed with is the NASA team, and many teams across this country have really succeeded in spite of the challenge of COVID. We a year ago, I was one of those old fuddy-duddies that said, I'll never work from home. What's all that telework like? It's crazy. Those people are nuts. They're not nearly as productive. And the truth be told, we have succeeded very well. We've created a different way of working, and we've been very successful, as is evidenced by a core stage sitting in a test stand. So I would tell you that NASA didn't lose but a couple of weeks out of a year worth of efficiency, in my view, in getting this rocket going. So I'm not going to say that we've got a lot of COVID delays, because I'm impressed with the teams and they've done a great job. But with that, there are always technical challenges. If you were going to build a new car or a Jeep Wrangler, or the guys doing the Ford Bronco are a couple of years late, there are going to be technical challenges that there will be days where you get up and you go, I'm not sure how we're going to solve that.
Right.
And that's what's great about having one of the best teams in the world around you, is you unleash that creativity, you sit down, you think about things logically. And so I've been able to be part of several problems that we have gotten through, whether it's a friction stir welding issue where we did some tests of the samples and we said, that's not the right strength. Why is that not the right strength? And we were able to come up with a very strong physics-based understanding, made some very small changes to the piece that stirs that material in a friction stir welding, and essentially double the strength of that weld. And so having strong physics-based and imaginative people around you has helped solve those. There's been numerous problems like that. I mentioned that one, but there's probably 6 or 7 things that we've stopped as a program and said, hey, I didn't expect that. How do we solve that? Whether that's a shock oscillations from a booster that's impinging on a part that you didn't think was going to happen, and now it's going to get hot, or things like that. So we continually have challenges. But that's what's great about the NASA team, and they do a good job with that. And if you know the history of NASA, and it's probably the history of many groups, failure is not an option wasn't first probably said by Gene Kranz, but it certainly became famous with NASA. And if you get up and dust yourself off when you get knocked down, you can usually get through these problems, and we have.
Yeah,
absolutely.
So I was going to say, this stuff you're doing is not easy, right? I mean, how many gallons of fuel is on that thing, and how big is it?
About 700,000 gallons of propellant.
Yeah.
The largest cryogenic propellant, well, the largest, I don't know about non-rockets, but it's certainly the largest rocket propellant tank, period. But it's the largest cryogenic, which gives it that extra challenge, cryogenic propellant tank ever built. So it's huge, and it's great. Yeah.
Keith, I think we only use about 600,000 gallons of propellant to fuel the Flumadiddle rocket here.
Yeah.
at the space headquarters here in Gadsden, Alabama.
Have you guys been like cutting the propane tanks up and welding them together? Is that what's going on?
Yeah, like the farmer rocket.
Yeah.
There's a movie about that.
Yeah, the farmer rocket. Wasn't that Homer Hickam?
Yeah.
So, some people would ask, we're certainly have been in uncertain times. Not that this last year is the only time like that. But in these difficult days, a lot of people ask about the practical value of this kind of mission, or going to the moon. What's the end goal? What's the vision? We're going to hit some of these words. Keith and I are word guys, so we're going to come back to the idea of perseverance and vision and such later, and kind of get a little more philosophical about this. But where are we headed with going back to the moon? What are we looking towards?
Well, it's exploration, right? I mean, if you look back at cultures that you respect, whether that's a Roman Empire or the United States of America, or some other, the Ottoman Empire, those people groups were really characterized by several different things. They were characterized by, a lot of times, their science, but they're also characterized by their art and their exploration. So you could ask the same question about why do people care about art, or what color their car is, or whatever. But the 3 things that really characterize great groups of people are really their scientific achievement, their artistic offerings, as well as their exploration. And so this comment that you make is a really good one. But we're always going to have trouble, and we're always going to have these issues among us, and they're difficult issues. In the 60s, and particularly 1968 was a extremely turbulent year, and it's the year of Apollo 8. It's the first time that we sent anybody outside of our Earth orbit, when we sent the 3 guys on Apollo 8 off to the moon. And that year was the year Martin Luther King Jr. was assassinated. And it's the year Robert Kennedy was assassinated. And it was an election year.
Vietnam as well.
And Vietnam was going on. And there were many people that called for an end of Apollo because the money could be spent on other things. And so I understand that. And I sympathize because I want those things to end, just like all of us do. But I would suggest to you that not just as a great people group, as a nation, but, you know, as a group of people that want good things for other people, we can show them how to aspire as a group for greater things. And we will have that hunger to go on. You know, when 1968 was going on, people were still climbing Mount Everest and people were still doing other things. And so that's what we're doing. We're doing those things that we hope will inspire mankind to look beyond the immediate issues and aspire to do greater things.
Absolutely.
That's a fantastic answer. I love the positive outlook there. You know, things have been tough before, but you just keep going and you keep exploring. I tell you, I've heard so many times we're better as an interplanetary species than not as the answer. And I'm glad you gave a much better answer than that, Dr. Jon. So there was something I was going to add on to that, though. You know, one of the reasons I feel like the Apollo missions fizzled out, if you will, was because of lack of public support. You know, the Congress don't get behind it if their constituents are not behind it. And so like Apollo 17 comes along, they have like some of the best camera technology on all the missions and not very many people watched it. And I've always felt like personally, that's like a kind of been there, done that kind of moment. Like we've accomplished it, now what? And so my fear is like when we get to Mars, it'll be similar to that. It's like it might be another 50 years because it'll be this been there, done that kind of moment. So do we have any goals beyond Mars? Like what do we do once we get there?
You know, first we need to get to Mars. I don't want to say we don't have goals beyond Mars. We have a great team of people working on that. The good news about the engineering side is I'm very focused on individual, you know, missions, and so the moon and Mars. You know, to address your comment though, Keith, you know, the public will wax and wane. It's kind of one of the great things about who we are is that we expect more, and that creates in some case more, right? Like you're not happy with your current iPhone, so you want more features. So they go get more features, right? It's part of who we are. And I'm not gonna seek to change any of that. That's just kind of what's embedded in us. If you look back to that 70s, and there's a great book called After Apollo that really addresses this, what we lost really wasn't the public excitement, although certainly less people watched, you know, and Apollo 13 famously wasn't even on TV when they thought they were on TV, right? You know, you got Jim Lowell up there like spinning stuff, you know, and you know, and his wife and kids are basically the only ones watching, maybe, you know, with a couple of NASA guys, and they recorded it for later because they didn't want to interrupt the prime time black and white TV shows, right? You know, that kind of thing. But the reality is, if you read that book After Apollo, what we lost is we lost the political will and the funding. Apollo was very expensive. And, you know, as we've alluded to before, we had reasons that we did that are a little bit different than what we're doing now. And so that mission that we set out to do when John F. Kennedy gave his speech in 1963 at Rice University, and then also talked earlier that year at the State of the Union, what we did is we achieved those missions, and we had done what we said we would do, and we were afraid of failure at that point. And so from a political side, if we're going to pump all this money in, and we've been successful, albeit a very dangerous mission, and we've got 12 guys to walk on the moon, we brought these 3 guys back that, you know, might not have lived had we not been very creative in Apollo 13 solution space. You know, what happened is like we're pumping all this money in, and if we fail now, this is not a good thing. So we lost political will and we lost funding. So SLS, you know, didn't set out to address all of those things specifically, but I do think that there is political will, bipartisan political will to keep the missions going. I don't control that, but I would suggest that it exists. I would also suggest that what I mentioned earlier about trying to make a sustainable, affordable, long-term plan, you know, this will not be the same percentage of the gross domestic output of the United States that Apollo was. I think Apollo did what they set out to do, and it was great. And I agree with you. I hate to see the hardware now sits in museums that would have been flight hardware. And for all of us that like exploration, that's a little bit sad and challenging. And we haven't been back for, right at 50 years. It'll be slightly over 50 years before somebody steps on the surface of the moon again. And so it's been a long time. As far as Mars go, Mars is a very unique challenge. It's a long way away. As a group of people, I like to say people group rather than species, but we're pretty fragile. Like I keep my house at 72 degrees plus or minus 1 degree. Right. It's pretty hostile out there in space, whether that's high energy neutrons or the fact that we don't have gravity and we've got buoyancy and we can cause blindness. So we've got some things to learn, and we're going to learn those on the moon so that we don't do something stupid going out. You can imagine if you're taking that boat, back when Christopher Columbus took a boat and he went over and found the Americas, and settled what is now like Santo Domingo and the Dominican Republic and all that. Right. You can imagine that he didn't take a boat that he could only get out into the harbor and get scared and come back, right? Right. So it keeps telling me I'm going to sleep, my computer does. So I guess NASA wants to make sure that I'm awake and working. So.
Yeah, absolutely. Well, you tell them you had a highly important meeting with the incredibly influential podcast, Flumadiddle.
So did that answer your question there?
It really did.
Yeah. I never really thought about the fear of failure being such a motivating thing there for kind of scrapping it, and that does make a lot of sense. Yeah. I
want to riff on the idea of space exploration because here at Flumadiddle, especially me personally, that era I'm just a few years younger than you are, Dr. Blevins, maybe about 3 or 4. And Keith, he's a young child in our eyes. But anyway, that era of history from World War II up through the 70s when I grew up, that Cold War era, it was still kicking seriously when I was a kid. So, the Cold War was definitely a motivating force in those early missions, up through Apollo, the USSR, USA, the space race, impassioned presidential speeches from Kennedy, we're going to set a man, on the moon by the end. That kind of motivation, how do we replace that without that kind of competition? And maybe that's part of what you do. I know you reach out and you share on podcasts like this. How do we get people excited about this, about future space exploration? How do we kind of motivate and push that with the general public and just everyday guys who love this kind of thing?
I think we succeed, and that's how we motivate them. I mean, I like talking to podcasts, and I think we live in a different age today where information is available, and so I like distributing information this way. I think it's great. Actually, you can learn how to do a lot of things on YouTube and podcasts and all that. Yeah. But I don't think that's really the motivational secret. I think the motivational secret is to dream great things and then go attempt them and make every effort to succeed at them. This exploration thing, I think the analogies really do hold back around the time of, Christopher Columbus or others too, right? They didn't know what was over there. There's some motivation that was money, right? Like, hey, we can get to the Indies, right? Like we can start trading spices, Right. There's resources on the moon and other places. And if you looked at the National Geographic Mars kind of pseudo documentary kind of fiction stories that they did, there's a series called Mars. If you watch that, there was a group of people motivated by the resources, right? And so there's just a lot of different things that people will be motivated by. And I don't think it's so simple as to imagine just being exciting and then everybody wanting to follow. I would suggest that the same thing probably happened to that group there. They come back from their trip and they're like, hey, we found this place and people live there and we've got bananas, right? And everybody said, that's cool. And then the second trip, like, that's pretty cool. And then the other people like, that's Christopher Columbus. I think he's done 4 voyages by now. I think that probably existed back then too. And I think it's, I'm just not, I guess you could say I'm motivated differently. I think this is a great mission and I'm glad to be part of it. And I think that there's enough people that really want to go do that. I do think it's our job to make it affordable and sustainable. Right. Now, you mentioned the competition, John. Right. And how do we do that? Competition. I would suggest to you there became other pulls, right? Like there was competition. I like these Christopher Columbus analogies, I guess, but there was this competition back then, right? Like Portugal sending people,
Right.
Spain sending people, but it didn't stop that entire, transfer of people from Europe to North America when the competition stopped. It really just started then.
Gotcha.
So I don't know if I would suggest that competition is the only secret. Now I'm sure there are people that are out there competing, and some people live in that mindset of, I'm going to run faster because my neighbor is just a little bit faster than I am or something. I'm sure that exists, and probably not in Gadsden, Alabama, I'm sure, but maybe somewhere else. But by the way, my dog came from Gadsden, Alabama, so I'm very fond of Gadsden.
Well, hello to your dog. What's his name?
Brom, Brom, a dragon rider, and in the Aragon series. So,
oh, that's awesome, man.
So it's actually my son's dog, so I can't take credit for any of that. So, but anyway, I don't know if that fully answered your question, but
that's great. That really is good.
Speaking of competition, with the private companies, you mentioned like Boeing and stuff getting involved and helping you guys. What about companies like SpaceX and Blue Origin and all that? Do y'all have collaborations with them, or is it more competition? What is that like?
Well, generally they're funded by your tax dollars. Now they are a little different, some of those companies, and the nuance really isn't about their funding. It's some of the companies that you mentioned, like SpaceX and Blue Origin. They're kind of venture capitalist, privately held companies, and so that's different than say a Boeing or Northrop Grumman, just because the Stock Exchange Commission and others regulate those publicly held companies. So it's easier to see the books and whether they're making profit or making a loss and all that. So there's probably some things that aren't in my purview as an engineer, not a financial guy, but to talk about. But ultimately at NASA, and we're not the only player in space, right? There's other groups that do space work, send satellites or GPS and all that. But in NASA world, we certainly use all of those companies. Now, here's the thing about it. It isn't just like we're getting help from Boeing. They're building a significant part of the SLS, right? I mean, and it's the same with the commercial crew and say the SpaceX. Now, do we help them? That's a very good question. We do. It's a small community. I have friends that worked in my laboratory back when I was a researcher that now work at SpaceX, and they've made a career out there in Hawthorne, California, and others that left NASA and worked in McGregor, Texas, where they test engines because we have big engine facilities. We test a lot of the engines for Blue Origin at NASA facilities. There's Space Act agreements. They pay for that work. Now, sometimes we're paying them to develop something that they then, test on our facilities, and part of that money comes back out. But there's a lot of, it's a relatively small industry. You've got like ULA and Boeing and Northrop Grumman and SpaceX and Blue Origin, and there's a lot of transfer back and forth among people. And I'm glad to be part of that industry. But yes, we certainly help them. I've been to Hawthorne, California, and back when they didn't have any success recovering stages, because I worked on stage recovery for previous rockets, and met with a lot of people, and we give them advice. They're American companies doing good work, and we want them to succeed. And we should all be excited that astronauts are flying on off American soil on American-made rockets, just like we did in the shuttle program, and now we're doing it with different rockets and different companies. So
we talked about motivating people for space exploration. Didn't that latest what was it, Perseverance? It found all kinds of gold and diamonds, right, when it landed.
Are you in need of some diamonds?
I'm just trying to get people motivated,
I'm sure that there's some entrepreneur somewhere who's got a calculator to figure out how much it's going to cost him to go get, 10,000 pounds of diamonds.
Yeah,
and flood the market.
Keith is the entrepreneurial mindset here. I'm more of the creative, technical force behind Flumville.
It's good to know how that operates.
We're going to turn the corner a little bit, just a little more fun stuff. For us, or at least for me, I'll say, my whole draw to NASA is the story. Those early Mercury, Gemini, Apollo missions, the movies, the books, the documentaries, that kind of thing. So we want to ask you about that a little bit. What do you think, in your opinion, we will not hold you. NASA cannot hold you responsible for this. So this is just your personal opinion. What is the best? What are maybe one or two of your favorite movies related to space exploration? Any of the previous NASA missions? You have anything you tell the people? Hey, go check this out. This is awesome.
Yeah, I love that kind of thing. I don't want to limit, and as you said, this is me speaking, maybe not some NASA endorsement, but I do like from a video series, I like From the Earth to the Moon series, and you guys may have seen that. And if you haven't,
recently,
I think it captures that age and that worked very well. I mean, next time you see Tom Hanks, you'll probably salute him. You'll think he's Jim Lovell, the astronaut. And that was born out of the Apollo 13 movie, which is a great movie.
Right.
His desire to go do that. And so I really feel like for Tom Hanks, that was probably labor of love, and he did a great job with that. And it's one of my favorite series. Now you've got to invest time in that series. I don't know how many hours it is, but it's really good if you want to see that. I will tell you, this is a podcast, and I have a favorite podcast that I think is incredible for the history. If you haven't listened to Moonrise, which was produced by the Washington Post.
Okay.
I think Lillian Cunningham was the producer out of the Washington Post. It was really done for the 50th anniversary of Apollo missions in 2019. But it's a fantastic podcast.
Okay.
And so, anybody who listens to that podcast who wants to shut it off isn't a fan of space, because you can't put it down once you start listening to that podcast. It's great. It really meshes together some of the things of our society too, like art and science, and how Warner von Braun worked with Disney, and so some of the things that you're talking about that I'm not particularly good at, like inspiring folks, it talks a little bit about that and why people got inspired. And it talks about the politics, and people forget Dwight David Eisenhower was president when Sputnik flew. And it wasn't Kennedy at the time. So, and so anyway, it talks a lot about those things. And there's some tapes that have been released, presidential type tapes from Kennedy, that really we don't hear that side of the story of Kennedy's own fascination with space, but then also his concern, like, what have I done? Did I just spend too much money? How's this going to play politically? In public, he was quite resolved, but in private, he still had some concerns, and so that plays out in that podcast of Moonrise. So that gets my first recommendation as a podcast, Moonrise.
Well, I will definitely have to check that out.
Yeah.
I've gone back. I've been listening to a BBC podcast called 13 Minutes to the Moon.
Yeah. They got 2 seasons. Excellent. Yeah. Oh, yeah.
That's a really good one. I like that. Yeah. Keith, I just like to hear Keith say this next word. So I made him ask the second half of the question. I like to pick on Keith. So Keith, on that same note.
Well, he wanted me to ask you, what's your favorite documentary?
Not documentary, but documentary.
Documentary. Well, my favorite documentary was, all right. So, hey, we're on a podcast. You're asking me, you didn't just ask an NASA guy. My favorite documentary, my kids could answer this question. My wife could answer this question. My 3 dogs could probably answer this question. Okay. It is Ken Burns' The Dust Bowl. That is my favorite documentary. Now, if you could see, John, I want you to just rewind when you watch this podcast or video, because the look on your face when I said the Dust Bowl, why the Dust Bowl? I just like that documentary a lot. And by the way, they take clips from the Dust Bowl and they use them in the movie Interstellar. So the Dust Bowl, when if you see the movie Interstellar, right, which is quite a science fiction movie, and you see the people, remembering what it was like on Earth, when they're interviewing the folks, that's actually just clips from the Dust Bowl documentary. So it's not related to space. I love space documentaries. I love all that. But my favorite documentary, I like all the Ken Burns documentary. I love the one on the national parks, and I love the Civil War one and the recent Vietnam one and the country music one. All of them. I like them all. But the Dust Bowl is my favorite set of documentaries.
I will say this, Dr. John, is From the Earth to the Moon is what got me interested in doing a podcast about this. I watched that whole series in probably just a few days. I mean, it is like 9, I guess, episodes or something, but it was outstanding. I guess you would call it like a docu-series or something. It was a
docudrama, I think.
Docudrama. Yeah, there you
go. Because they fill in, they fill in what they don't know with things that are reasonable,
Right.
but it's good. Yeah, they did a good job.
Good. Yeah.
Well, John, we want to end on a kind of an inspirational note that, like we talked about. So I'm going to throw the first part of this question over here to Keith.
Well, the history of NASA, from Mercury to Gemini to the Apollo missions, even to the space shuttle flights, it tells an inspirational story of vision, imagination, and perseverance. And we wanted to use those three words, Dr. Jon, to let you share with us how they connect NASA's history to the Artemis mission and beyond. So let's start with the first one, vision.
The vision of Artemis is to expand our horizons in knowledge in the universe.
All right. Our next word, I love this one, imagination.
It's the imagination of this group of people in this country and across the world that are going to solve the challenges that we have in our exploration.
And the last one's definitely a good one.
We've hit on it a little bit, but we're going to pitch it up to you
but
like a softball.
perseverance.
Oh, perseverance. It is only by perseverance that we achieve the goals of mankind in any of our fields.
Yeah.
Well, that's something we want to encourage people. It's been a tough year. Keith and I, all through this very heated coronavirus time, political times of the past year, Keith and I are very big on coming together, no matter what your perspective, no matter what your political views, no matter what your thoughts on a particular point of theology, whatever that might be, to come together as friends and brothers and neighbors and be able to communicate in a reasonable, intelligent, and loving, accepting fashion. So that's kind of what we try to do here. And we want to encourage all the people that are watching this, continue to persevere. There's always hope on the horizon. It's drawing closer every day, or we're drawing closer to it, however you want to look at that. So, Dr. Blevins, we want to just ask you one more little thing as we thank you so much for joining us today and taking time out of your busy schedule. We've talked a lot about the space program, but for our listeners who are interested, you mentioned your dogs. Tell us a little bit, are there some things that you enjoy doing, hobbies, other things you do to kind of keep your head clear, to things that you enjoy that have nothing to do with being a rocket scientist?
Hey, this is wonderful that you asked this, John, because for everybody out there, I think particularly the younger folks, they get excited about what they want to achieve in life. And sometimes we forget that what we do isn't who we are. It's just something we do. And so, yeah, my wife and I have been married 33 years this year, and our 3 kids. So I love the family time, and I'm privileged to teach a college class at our one of our local churches here in Huntsville. And it's a wonderful group of folks. We mentioned flying. It's something I do, something that I like to do. I like to hike. I know it's probably crazy, but as an engineer, I like to spend time alone. I like to read. I've got about 1,000 hours flying in airplanes alone, and sometimes that's quite therapeutic. And so things like that are things that I like to do. But you know, while you've got your viewers on, I think I really admire that you're encouraging them to just get out and do things and persevere through this difficult time. But I would suggest just put one foot in front of the other. That's how we persevere, right? We just get up, dust ourselves off, and if you're feeling low, go for a hike today. And remember, what you do is not who you are, and you can change those circumstances. So
that's awesome. You know, that idea of perseverance and one foot in front of the other. Speaking of documentaries, I've watched several on the ascent to Mount Everest. And as you get up towards the summit, you've seen some of those pictures, these guys with these parkas pulled over here, they've got the rope and they are literally inching 3 inches at a time. I mean, just head hunkered down, 1 foot in front of the other as the storm kind of batters them. So that's a beautiful image of perseverance. So everybody keep going. Don't give up. There's always hope. And if you want to contact Keith and I here at Flummadiddle, you can reach us at doyouflummadiddle@gmail.com and
doyouflummadiddle.com. And Dr. Blevins, do you have anywhere online that the people could reach you or find out more about your stuff?
Not that I would admit to. I said, not that I would admit to. No, I'm really busy doing this rocket and doing the other things I mentioned. And I'm NASA.gov has all the information that your audience would want to see about the Artemis missions, and certainly they'll see me here and there on a podcast or something as it goes along. But NASA.gov, great place to see what we're doing. So
awesome.
That's good.
Well,
We appreciate you being on.
thanks so much. Grace and peace to you and your family. Keith.
That's it.
All right. Well, I've been John, and this is
Keith.
And I'm John.
and this has been Plumadiddle. Thank you so much, Dr. Blevins.
All right, grace and peace.